Alright, so this is my second video of my LeetCode problem. So today I'm going to solve another LeetCode problem, which is I solved yesterday. And in this LeetCode problem, I apply a algorithm that I learned yesterday, which is Moore's voting algorithm. This is a pretty easy kind of concept, but it's going to take a time. Okay. As you can see, the problem is basically mirror key elements. So in this problem, they're giving us a array. It is not array, actually it is a vector. I mean, I already solved this problem. So we can solve this problem in three ways. I mean, there are three different ways, and each have the different time complexity. Time complexity. I mean, here we go. In here, the first thing what is done is basically we have to find the majority number inside this thing, which is three. That's the thing. And we have to find the majority number inside a array. And here it is two. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here's the thing. I mean, we have to divide by the majority. It's divided by the number of array, like how many arrays inside this, and divided by 2. So then we can get the majority number. It's a simple logic. So let's just solve this problem then. So to solve this thing, first of all, what do we want? First of all, we want the size. I mean, size of n. Then in here, what are we going to do is basically run. Okay, so I told you there's three ways we can solve this problem. Each have some different time complexity. Okay, the last one, the most optimized version is like Morris, Mooris. I mean Morris. My name is Morris, but it's Morris voting algorithm. Okay, so let's start with the brute force. I mean, how a normal human being is going to think and is going to apply, like solve this problem. So to solve this problem, what we need is basically run two loops. The first loop is going to run from 0, and it's going to like count the frequency of this thing. 1, 2, 3. It's going to like simply count the frequency, and if the frequency is greater than that, so it's going to simply just print that. Okay. So this has nothing. Okay. We have to run two loops. This the time complexity will be capital O, sorry, big O. I'm sorry. For we're going to count with element, not with the actual value. I mean, first thing, well, why count is equal to 0? Count is basically, you can say a frequency. You can just FRE. I mean, this FRE. FRE is for frequency. Then another loop is for int EL and UMS nums, and this thing is going to count that value. Like if this is equal to that, then it's going to plus our frequency, and if the end frequency is divided by the array, the number of this is divided by 2, and it then also it's greater than that. So this is okay. Let me, if, then we have to plus it, FRE, FRE plus plus, then that this. So now what we did is basically, so now let me explain you what I did in here. The first thing, I initialize n. I mean, n is the simple, I mean, is the size of that array. So we are getting the each value. If you are going to print the val, then you are going to get the each number. I mean, 3, 2, 3. You're going to get 3, 2, 3, the elements of the array. Then what is EL? EL also the same thing, the elements of the array, and we are the checking the first and the second. Like EL and the another. So let's dry run this thing. Okay, the first thing is going to run, the first loop is 3, then it's going to count the EL. Is this value and equal to element? Yes, this is equal, 3 and 3. The frequency is 1. Then it's going to check another condition we have to add here, which is right here, I think. If frequency is greater than n divided by 2, and then return value. We can return here a empty string. Empty thing in this thing. Okay, so the value is 1. Is this is smaller than the frequency? I mean, is this is bigger than the divided by 2? It is not. Then it's going to run again. Is this is equal? The first 3 is, it's not. Then it's not going to run again. I mean, And you can understand if you have the basic knowledge, and if you can understand the basic loops and the what is it, statements, I mean, then you can easily understand. And we can run this also. So let's copy the case 1 and case 2 are problem solved. And if we did submit, it's going to show us the memory, and it's going to use the highest memory because this is the easiest solution normal human being can think. And here you can see 2585 ms. This is too much, and like 5% of it. It's not good, okay? We're using too much of resources. We're going to use only one loop, and we're going to use a for loop, not for each loop that I was using, that is for each loop. I mean, these are for each loop, not the for loop. So let's solve this in another way. In here, first of all, we have to do is basically sort our array, because this array is not sorted. We want a sorted array. So that's the reason we can use a sort algorithm, sort, and we have to give the, so we are basically as simple as that. We're just sorting this array. Now it's going to 2 3 3. So now we're going to create some values, okay, some sketch values that are going to store, because we in here what are we going to do is basically check if our statement is right or wrong. So to check this, we're going to say int FRE frequency is equal to 1, because now in here we're not running two loops. So that's the reason we have to set this a 1. And then there's int answer. So we're just referring the answer is the first value, which is 0. The first integer, which is like the sorted array should be. And let me give you an example of how it's going to look. So this is how this array is going to look after sorting this array. And here is the thing. Okay, so in here we did this, then we have to create int. So here's the thing. It's just as easy as that. We are referring a frame. The first is frequency. We're setting the frequency because we're starting with the 2 number. So we're assuming that our answer is 2. We don't know though, because we're not performing any kind of functions right here. Not yet. Okay. So we're referring our answer is 2 and the frequency is also 2 because that is the answer. So there should be a frequency. So it is wavelet 1 and 2. Then we're going to run a for loop for in I is equal to 1, because like as simple as that, I mean, we already have the 1. Then I should be smaller than n. So this is a loop as simple as that, nothing else. Then we're going to check if our nums bracket I is equal to nums bracket I minus 1. Okay, so right here, this is the important thing I'm doing right here. I minus 1. Where did I do I minus 1? Think of it. Let's take a let's take a back step and think of it. Why I did I minus 1? I is going to start with 1. What is 1 value? Is in array is 3. Index number, I mean index 1 is equal to, in here the value is 3. So we're checking 1 and equal to our number is answer, I mean 0. Is two things are same. If this is same, then simply what you have to do is basically FRE plus plus. That's it. Khatam. And else, if this is not right, then what do we have to do? Then what we have to do is basically to set our frame is equal to 1. We want to reset our frame and we're going to answer is equal to nums bracket I, which is reset our answer. That's it. So if the frame rate FRE greater than then answer. Okay. Did you understand what I did? I mean, nums bracket comma. Okay. So in here, what I actually did is basically I run a loop. We're starting with index 1, not with index 0, because we have to check right here. I minus 1, I already did. Okay, we're going to check with index 1, and if this and this index are the same, index 1 and index 0 is the same, then it's going to plus it. This is 1, and if this is not, then it's going to reset the frame. I mean, with the answer, I mean, we're going to change the answer also. This is this, I mean, the zeros value, then this is the int value. This will be, I think, 3. Then it's going to check 3 and with the 3. If this is right, and if this is the divided, if the frequency is bigger than the n divided by 2, then it's going to return our answer. And this is the time complexity is something around like big O log n, I think. Big O log n. I think big O log n, yeah. If you're really able to understand, then you have to learn more about loops and the statements. And in here, I'm not using any kind of algorithm. Like, this is just a simple logic. The algorithm I want to use right here. Now, third solution. I told you now, we can solve this problem in 3 ways. This is the most optimized version. Okay, let's just run the time complexity is giving us. Big O, and here you can see big O and log n. Yeah, this is small, but we can do more also. So let's solve the most optimized version. In here, I'm going to use Morse voting algorithm. So look, try to understand what is Morse voting algorithm. It's basically, look, inside array. Let's suppose this is the array. Okay, this is a sorted array, but the same thing with the unsorted array also. Okay. So what are you going to do is basically set our frequency with 0. If we're going to check that if our this value and this value are the same, in here also we're going to run do, which is going to check this value and this value is going to check, then it's going to sorted array will be 1. And if this and this is not equal to, then it's going to minus the frequency. We're not going to do the like frequency plus and restart the frequency. No, we're going to minus the frequency, whatever. In the end, the frequency is not going to give us the correct frequency. It's just going to give us a actual answer. In here, we're going to depend upon the answer, not the frequency. I mean, yeah. In here, right? Okay. In the rest of the problems, what are we going to do? In end, we're going to like divided by n. But in this Morris voting algorithm, we're not going to divide it by n. I mean, like we're not going to compare our frequency, how much this number of frequency is happening. We're not going to check that. So let's solve it. Okay. We have one int FRE is equal to 0. Int ANS is equal to also 0. And int n is equal to minus dot size I is equal to 0. This is a normal loop. I mean, normal loop how it's work on. I plus plus. Now, the main algorithm I'm going to write. So in here, we're going to check if our frequency. So if the statement is FRE double equal to 0, then so यहाँ पे हम लोग इसको ना रिमूव कर देंगे. यहाँ पे हम लोग अभी इसको आंसर अज्यूम कर लेंगे. ANS is equal to NUMS nums bracket I. हम लोग आंसर को अज्यूम कर लेंगे nums bracket I. Just as simple as that. नम्स हम लोग इसको ना अज्यूम कर लेंगे कि हम लोगों का आंसर ये वाला है. Now in here, what are we going to do is basically if our ANS is equal to NUMS dot I, then FRE plus plus. That's it. This is the whole algorithm of this thing. This is it. What we have to do. This is the Morris voting algorithm. There's something wrong. I'm not interested. Okay, let me try to explain you how this algorithm is going to work. So in here, we initialize our values to the frame rate 0, answer is 0, then int is equal to n, the size of the n. Okay, the first loop is going to count through n, the size of this array. If this condition is right, if our frequency is 0, then we have to evaluate the answer 1. I mean, if this frequency is 0, this is the first value is 2. Now our answer is 2. We don't know what is happening. The answer is 2. Okay. Then this loop is going to run again. If this answer is 2, then it's going to answer is equal to answer. And if these two things are right, then it's going to like 2 and 3 are right, then it's just simply I am yeah, this 2 and 2 3 is going to right, then it's going to plus the frequency is going to be 2. I mean, it's going to be 0. I mean, again, because these and these are not same, then it's going to run the loop again, and these 3 and 3 is the same, then it's going to give us frequency minus minus plus plus. The answer is the same. I mean, I'm not good at explaining things, but it is going to run. And if you sum it, this is the most optimized solution of this problem. Yeah, the 0 ms and 100%. This is what I mean. This is n, I mean, big O n. Probably this is big O n. We can't deceive the time consuming compatibility. If you want a better explanation, watch another video on that would be better. Yeah, this is for the video. 24 minutes. Damn.